With domain and range, you just have got to remember that domain, those are going to be all possible x values. Range will be all possible y values. So here's a great example illustration of how you look at domain and range. So domain, you're going to read left to right. Range, you're going to read bottom to top. And then just a couple things to remember on the strategy side of it is you always want to start with your smallest number to the largest number. And so if it's continuous, like this is a continuous one, you would have this notation that looks like this, the inequality notation. And if it was just points listed out, then you would have number, 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 number for the x's, and then number, number, number for the y's. So continuous, use the notation with the inequalities. This is including it. This is not including it when there's no line underneath. And then you're going to put x in the middle for domain. That's if it's continuous, like this. If it was just points on a graph, then you would have the list of numbers, so the list of the x, and then like I said earlier, list of the y. Same thing for the range, same concept, except in the middle you're going to put the y, you would not put the x. And then the other thing that you want to remember is if you have arrows on the end of the lines or the curves, depending on which direction those arrows are pointing, either your domain or range, or maybe both, will be all real numbers. So just take a look closely. If there's arrows, utilize what you need to utilize to say for domain or range if it's all real numbers. So with domain and range examples, it's going to be important that if you have a word problem, it's going to be important that you can kind of break apart what is representing the x value, what is representing the y value. So a lot of times with domain, we call that the independent variable, meaning that it doesn't depend on anything else. So time usually is an independent variable, or I think that's the best example I have right now. Time, because you can't change it at all. So that would be like what you're plugging into the equation. Your dependent variable is going to be what you get out of the equation. So maybe total number, total savings, total bacteria that have grown, or whatever it might be. So anytime you see the word total, if you are able to and need to, you can always use the gear on the Desmos to help you figure out the x values and the y values, especially if it's something that's like listed out like this problem on number 5. And then on here, you just want to remember, pay close attention to the points on the end, if it's an open point or if it's a shaded point. Something to think about. These open points, you would have to use the inequality sign that's just greater than, but if it's shaded, you would use greater than or equal to.